No, this is exercise 14D, and we're on question 1. Okay, a rod of length 2L and mass m is free to rotate about a horizontal axis through one end. So look, we're going to construct this rod here. Okay, once we have this rod, it's able to rotate around its own its own axis, like so. So the axis, if you will, is the board. Okay, that's the XY axis. Z is going to be the line going straight through the middle, which it has to rotate around, i.e. your pen is here and the rod is rotating like that. Okay? Now, through one end perpendicular to the length of the rod, that's what it means. It goes straight into the page. Okay? It performs small oscillations, find the periodic time. If it performs small oscillations, what does that mean? Our proof that we just did is in play. Okay, so basically what we did in for the proof works, because theta equals sine theta. Okay, so next thing, we're going to get our moment of inertia. It's a rod held at its end. Alright, the general formula is 4ml squared divided by 3. That's for length of 2L and mass of m. Is this the same system? Mass m, length 2L. Standard, no adjustment required. Okay? Then we go for a compound pendulum. Now, is this in your tables? 2 pi, the square root of inertia over mgh. Yeah. That one is in your tables, yeah? So that's perfect. It doesn't matter of looking it up. Okay? So here, what is h equal to in this question? H is defined as the distance from your axis of rotation to the center of gravity of your object. The center of gravity of the rod is dead center. If it's of length 2L, that means its center of gravity is the distance L away. So basically H equals L. Okay? So therefore your periodic time is going to be 2 pi. We're going to replace the inertia with 4 over 3 ml squared divided by mgl. The l's cancel, the m's cancel, and therefore our periodic time is going to be 2 pi, the square root of 4l over 3g. H is L, because H is not defined. It's not the height in this definition. It's the distance away from the axis or the point of rotation to the center of gravity of the rod. Center of gravity of a rod is always dead center. Okay. Now that that's done, okay, that's actually the end of that question. It's actually much easier than the proof. Okay. So we're going to move on to number 4 in a second. Do you want to leave it up for a second?
Can you please?
Okay, number 4. Okay. So number 4. A compound body consists of a uniform rod of mass m and length 2L with a point mass m attached to its endpoint. It is free to rotate about a horizontal axis through the other end of the rods, perpendicular to the rod. Find the periodic time of small oscillations. Once again, small oscillations. Okay, so this, whatever we're doing will work here. Okay, so look, we'll just get our rod. Okay, call this the turning point. Put a point mass on the end. Okay, that's interesting. Okay. Not what I wanted, but anyways, it's going to rotate around, down and around, very similar to what we had a second ago with this thing here. Okay, so it's going to rotate around, and remember that the point mass is at the end. Okay, point mass is at the end. Okay, now let's begin. Okay, so we're going to start off with we're going to call this point X. The center of gravity of the rod is L away. the point mass is 2L away. Now we'll start off with the rod. The rod has a moment of inertia about the point x, that's what Ix means for the rod, and it's held by its end, so it's 4/3 ml squared. No adjustments needed because it's mass m and length 2L. Okay. Next thing is we gotta talk about the point mass. Now the point mass, does anybody remember the formula for a point mass? It's m times its distance away from the axis, so it's mr squared, or in this case it's going to be m times 2L squared, okay, which is going to be 4ml squared. ml squared, okay. Now, when we add them together, what do we get? So we're going to get the inertia of the system. So the inertia of the system is the point mass plus the rod. 4/3 ml squared plus 4ml squared, and we get 16/3 ml squared. Okay, so that is basically all of this here. Okay, okay, so that's it there. Okay, next thing, what we're asked to do is we need to find out the point mass at the end. Okay, now we read the rest of the question. Is free to rotate about the horizontal axis through the other end, perpendicular to the rod. Find the period of times about it if it's really small. Okay, so what's happening is we have a rod, and the rod has a point X here, and it's mg in the middle, which is the mass in the middle. Okay, and then it has another mg at the end. Now, there's something that you haven't done before, okay? It would have came up in the statics chapter. It's what's called the, the moment of the system equals sort of like the system of moments. So the individual moments added together equals the moment of the system if you treat that as one object. Okay? So to go about doing this, what we do is we imagine that if we were to combine this full system together, what weight would be leaning down? 2 mg, wouldn't it? So 2 mg, if we were to take this as one big object. Now, for a rod, the centre of gravity is dead centre. But if I bias the mass to the end, if I make the end of the rod heavier, what happens to the centre of gravity? Does it shift left or shift right? It'll shift to the right. So that's where our new 2 mg centre of gravity is coming from. Now this 2 mg is going to be a distance h away from the turning point x, okay? So what we're going to do here is we're going to find out what is the distance h, okay? Now, so the sum of the moments equals the moment of the system, okay? Okay, sum of moments equals moments of system. So sum of moments is basically mg by L. Because remember, it's forced by distance away from turning point. And then this one here is mg by 2L. So it's going to be mgl plus mg times 2L. That equals moment of the system. The moment of the system is going to be 2 mg multiplied by h. Okay, you can take the mg's out of both sides. And what we'll get is 3L equals 2h. H therefore equals 3/2L. Now that we have that done, all we have to go about doing next is we have to find out what the periodic time is. You look up your notes, small oscillations. Periodic time equals 2 pi, the square root of inertia, over mgh. Okay. Now 2 pi stays the same. What's the inertia of our system? 16 over 3 ml squared. Okay. M on the bottom, still M. G still G. Oh wait, is M? It's 2M. Why is it 2M? We're treating it as the rod and the point mass combined. So it's going to be 2M bracket G bracket H. Now what's H? The H is the distance X, not to the center, to the new center of gravity. Oh sorry, yeah. So what's it? 3 over 2L, because we want those L's to cancel. Okay, so let's see what's going on here. Okie dokie. 2M, M, L, L. Now, I'm not going to risk this in the exam. I'm in the middle of exam. I'm just going to be careful about this. So what's it going to be? 16 over 3? 16 over 3 on top. Over 3. 4 over 3, yeah? So the square of all that is 4 over 3. Now just be careful about the G on the bottom, okay? So it's going to be 2 pi times 4 over 3. What I didn't include was the L and the G. Stays where it is. And then finally it's going to be 8 pi over 3 square root of L over G. And that's your answer. Okay? They're actually not the most difficult questions you've come across this chapter, okay? Do another one. Last one. What's the next one? Number 8, yeah? Now, show that the moment of inertia of a uniform square lambda of side 2L and mass m about an axis perpendicular to the plane of the lambda to a centre of mass is 2 over 3 ml squared. Okay? So look, what we have is, we have the, if you remember from back, we did a proof, okay? And the proof we did was for an axis going through the plane. Okay? So when we break it up into L, 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 and L, okay, we have 2 different axes, okay? We can call this IY and IX. Now the proof is that in general, if I have a axis that's going through the plane, not perpendicular to it, parallel to the plane, the proof is that it's a third ml squared. Okay, that was proven. That was one of our very first terms. Okay, now we're going to try and find out what IZ is. IZ is going directly through the middle. Okay, so basically, if I was to draw like a parallelogram, I suppose. If I was to draw something like that, this axis will be going dead center through the middle, going through the center of the circle, okay, or center of the square. Now that that's sorted out, what we have to do is find out what IZ is. So we're going to use the perpendicular axis theorem, and the perpendicular axis theorem says that IZ equals IX plus IY. Now because IX and IY have the same length, IX and IY are dealing with lengths of, total length of 2L. That means their original formula holds true. It's going to be a third ml squared plus a third ml squared, which is going to be 2/3 ml squared. And I'm just after proving what he wants me to prove. Okay? Now, can I skip on to the next part? Okay. So next part, okay, a thin uniform rod of length 2L and of mass M is attached to the midpoint of the rim of a square as shown. Okay, what's the rest of the question? I think you'll have it on the next page. Here it is. Find the moment of inertia of the system through the axis, through P, perpendicular to the plane of the lamina and the rod. Okay. So, what it wants me to do here is, I'm going to have to find out the inertia of the system, okay? So, if I write this out, to the centre of gravity, that's the centre of gravity of the rod, that's going to be L and L. The centre of gravity of the lamina is going to be a distance, it's going to be dead centre, isn't it? Because it's a square, okay? Squares and rectangles will be dead centre of the width and the length, okay? So, with this in mind, we're going to find out the rotational. What is the inertia about the axis P? Now remember, P is going directly into the board, okay? IP is 4/3 ml squared. Is it of mass M? Yes. Is it of length 2L? Yes. No adjustment required. The lamina is going to be IP. Now, we need to find out the lamina, okay? What did we say earlier about the lamina? We proved it in the first part. If it's rotating around its own centre, it's going to be, if the lamina is rotating about its own centre, C, what is its moment of inertia? 2 or 3 ml squared. We don't want it going through this point here, sorry, we'll call it D. We don't want it going through the point D, we want it going through the point P. This leads us to the parallel axis theorem, where if I want the inertia going through P, I need the original inertia, 2/3 ml squared. This inertia is located 3L away from the axis I want. Okay? So that, remember, the theorem is md squared, which is going to be m times 3L squared. This means its moment of inertia about P is going to be 29/3 ml squared. Therefore, the system, when you add them both together, system is going to be the two of them added together, which will give me 11 ml squared when I add the answer of 1 to the answer of the second one. Okay. Done. When the system makes small oscillations in a vertical plane about the axis, show that the period of oscillation is, what's that, 2 pi square root of? Is it 11L? Divided by what? 4G. Let's prove this, okay? So, gonna have rod square. Okay, like last time, I want you to take the moments. This is the first mg is dead center, and the second mg is dead center again. Okay, L, L, L. Okay, now when we add them together and we treat it as one big rod, what happens? When we treat it as just one system, sorry, I'll replicate this again. Nope, that's not what I wanted. Okay, so this here, okay? Now, what happens here is, I'm treating it as one system. So what happens this time around? The centre of gravity is somewhere in between the two of these, okay? I don't know how far it is, okay? So I'll just put it out here. And I'm going to call it 2mg. I don't know if it is going to be there. It could be in the lamina itself. I don't actually know yet. Okay, sorry guys, be with you 1 second. So what's going to happen is we're going to take moments about the P. So the moments of the sum of the moments is mg times L. And then it's going to be plus mg times 1, 2, 3. 3L. Okay, and that's going to equal the moment of the system, which is mg, 2mg by h. Cancel the mg's. 2h equals 4l. H equals 2l. Then finally just put into your formula 2 pi the inertia over mgh. And what we get is 2 pi, what did we say the inertia was again?
11 ml squared.
11 ml squared. The mass is 2m, gravity, and h is 2l. And then what we're going to get is 2 pi square root of 11l over 4g. And that's it there, ready to go. Okay, thank you. Sorry about that.